Okay guys, welcome back to the IPC Flip Classroom. I'm Mr. Hawkins, and today guys we're going to be discussing measurement, dimensional analysis, and error analysis. Okay, so what does that mean? What is measurement, what is dimensional analysis, and what is error? Let's start with measurement, okay? And you're pretty familiar with measurement, I'm sure. You've always done calculations in the math class, and I'm sure in your old science classes dealing with different types of measurement. And some of them you might have seen American units, and sometimes you might have seen these other things like grams, liters, and meters, right? Well, that is because they are what is known as SI units, or System International Units. The American units I'll specify as we go along. The first of these is weight. Weight is specified in pounds and ounces, and that is an American unit, okay? And weight has to do with mass, but it takes it a step further. Mass involves grams, okay? And grams can be converted to kilograms, milligrams, right? Any other type of grams that you want. But what weight is and how weight is different than mass is that weight involves gravity. So weight takes into account gravity and the mass of something. Whereas mass just tells you how much of something there is. Okay? So how much something there is mass, and mass with gravity will tell you weight. And we'll talk about this way more when we get into Newton's second law. The third is volume. Volume is measured in cubic centimeters, cc's, or liters. cc is just an abbreviation for cubic centimeters, just another way to write it out. You'll see it on maybe a few assignments. Centimeters cubed, though, is a measurement of volume that you'll frequently see. And liters. Volume is measured in liters for fluids. Okay, so if you go to the store to buy a liter of cola, you're buying a fluid liter of that cola, and it tells you the volume of the Coke that's in it. Okay, so distance is another type of measurement. Distance in America is measured in miles, feet, and inches, and distance across the pond is measured in meters, okay? So whereas we would have miles per hour here, the cars in Britain or Germany or something like that would measure speed in meters per hour, or kilometers per hour probably. And so that's a clear distinction. One thing that makes US units a little bit tougher to convert than the SI units. Temperature is another type of unit, and temperature for us in America is measured in Fahrenheit. Water boils at 212 and freezes at 32 degrees Fahrenheit, correct? Well, in Celsius, it's 100 degrees Celsius and 0 degrees Celsius, which it boils and freezes respectively. Kelvin is a little bit different. We'll talk about all three of these way more in depth when we get into thermal energy. So that's important to keep in mind. Time is another measurement method, and it is measured in minutes, seconds, and hours across the world, okay? So everyone uses time in the same units. So now we come to dimensional analysis, and we have all these different types of units, but how do we get from one unit to another? You're going to use dimensional analysis to do this. I want you guys to find a method that works best for you and makes you feel comfortable. I'm not here to pressure you one way or the other. So how do you do dimensional analysis? And I'll show you on the interactive whiteboard on my iPad. So we're going to convert 5 grams to 5 milligrams. Okay, pretty straightforward. How do we go about doing this? Well, if you're going to convert this, you can do the simple mathematic way, using the conversions from King, Henry, died, Monday, drinking chocolate milk, right? Well, in this case, you have meters, liters, and grams. In this case, we're dealing with grams, and you want to convert it to milligrams, so you move the decimal to the right 3 times, right? That would be an easy way to do it. You'd get 5,000 milligrams, which might be right, and I'll show you here in a second that it actually is. But the proper way that you want to do it is using dimensional analysis. So how do we set up a dimensional analysis? Well, we set it up like this typically. We have our starting unit over here. That is, in this case, 5 grams. We're wanting to convert it to milligrams. So in order to do that, we have to have 1 gram contains how many milligrams? It would actually be 1,000. And in this case, you would multiply the 5 grams by this conversion factor, 1,000 divided by 1. Okay, when you do that, you get 5,000 milligrams. Okay, just exactly what we saw earlier. Does that make sense? Good. So as you go about doing conversions, you're going to use dimensional analysis in this class. In dimensional analysis, you converted between different types of measurement. But in error analysis, you're looking at the error of an observation, okay? So it happens all the time. Nobody's perfect, and so error is a frequent thing in our world. And the important thing to keep in mind is the lower the error, the better the result was, okay? So you want to have small amounts of error. And how do you calculate error? You take your observed quantity and subtract it from a known actual quantity, something you should get, and you divide it by the actual quantity itself, multiply that by 100, and gives you error. So how could we do that, right? That doesn't make any sense, Mr. Hawkins. Well, actually, it's actually pretty easy. Let me pull up my iPad again, and I can show you how you would do a sample problem using error analysis. So say we're wanting to find the volume of a cube. How do you find the volume of a cube? Simple. The volume of a cube is equal to the length times the width times the height, right? You're and
some of the area times the height, and that's also true. But, so how would we do that using these numbers? 6 times 5.08 times 4.286, correct? Pretty straightforward, right? Centimeters, 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 and centimeters. Multiply all those together, and it leaves your answers in centimeters cubed, okay? So we can see how that dimensional analysis, or how volume actually can be measured in centimeters cubed. But what is the correct answer to this? The answer I'm getting is 130.64, roughly, centimeters cubed, okay? So I rounded a little bit. Now, let's say that this was the actual answer, 130.64. Okay, let's say that Johnny over here decides that he wants to write his answer as 130, okay? So we remember from the other page on the slides that told us that to find percent error, we have to go 130, the observed quantity, minus the actual quantity, 130.64, all over the actual quantity, 130.64 times 100. Okay, and that will give us percent error. So what would that be? The quantity for error I'm actually getting is 0.48 and some change. Okay, so roughly 0.48%. That's under the 5% error quantity that you have to strive for in this class. Okay, so you would lose no points if you did round your answer to 130 in this case. Okay, now that's not always the case, so it's always important to calculate your error. Really easy thing to do using that formula, okay? If you guys have any more questions over the content of today's lecture, make sure and write them down and ask me during the Gimme 5 session tomorrow, or send me a tweet or respond in a comment on Edmodo or YouTube, and I'll get back to you with feedback as soon as possible. Otherwise, you guys have a